Hey people, welcome back. And in today's session, we will be learning about the one sample t-test. If you remember, in the last session, I explained you that which are the statistical tests we perform in what conditions. So if you did not watch my last video, just watch the last video and you will understand which are the tests we perform in what condition. So today I'm going to explain the first test when you are comparing the target with the observation. We will be using one sample t-test where we are comparing the central tendency as a mean. So you have a target value average. Against that, what sample observation you have? You are comparing the sample mean with the target mean. The condition for that, your data should be parametric or normally distributed. So how do we perform the one sample t-test? Let's understand first some prerequisite. So one sample t-test is a statistical test which is used to determine whether the unknown population mean is different from a specific value. Specific value is your target value or target average, and unknown population mean is the data which you have collected. You are comparing that value. Commonly used to compare the sample with the known or hypothesized value, which we call as in population mean. So to perform the one sample t-test, we have the following assumption that we have to make. One, the data values are independent, meaning they are not related to each other, which means all the values data what you have collected, they are independent. Then data values are continuous in nature. They can take any value within the given range. Data values are obtained via a simple random sample from the population and assume your data is normally distributed. The steps that we involve to calculate the t statistics. First, the one sample t-test will involve the following. Step 1. Calculate the mean, standard deviation, and sample size of the given data. Compare the sample mean with the hypothesized value, and you determine then the appropriate statistics and the p-value based on the comparison. So the statistics denoted as t, which we calculate as in t statistics, is calculated by dividing the mean difference. How much is the difference in the mean? By the standard error of the mean from the sample size -1, because we are calculating for the sample data denoted as an n-1, and the degree of freedom for one sample t-test we take as an n-1. So you will be calculating the t statistics, meaning you will see the average difference value between the two value and you are dividing that by the standard error, and then we'll get the t statistics, and against the t statistics we will be calculating or we will be checking out what is the p value in the t distribution table. So two type of hypothesis will be there. One, we call null hypothesis, which will say no difference, which means the hypothesized mean value or the target value versus the test statistics p value what you calculated. If p value is greater than 0.05, that means it's a null hypothesis. There is no difference. Or in case your p value is less than 0.05, then it's a alternate hypothesis and there is a difference. So null hypothesis assume no difference between the true mean, which is your target value, and the specified value, while the alternate hypothesis will assume that there is some difference exists between the mean and the specified value. So the data does not meet this assumption, which means your data is not normally distributed instead of normal. So we can use the non-parametric test, maybe the sign test or Wilcoxon test, which I will be explaining in the next session. So let's understand how exactly the one sample t-test will work. Suppose you have any target value. Let's say this is your target value which you want to achieve. And now you have a lot of sample data, maybe 20, 30, 40 sample data point, whatever you have. And because this is one value, which is the target value, an actual observation what you have the multiple observation and all values cannot be same. So definitely your data will come with some distribution. like this is your distribution of the data, where you will have one center value or the average value of this data. Now I wanted to compare these two. So please remember the fundamental principle of any one sample comparison test is when this is your point of estimation, these average value and the target value. And if you look from this data perspective, so this blue line and this orange line, these are the two different values. You cannot say they are same because there is a difference between these. This difference is created here. So the way we compare, this is your mathematical value. Suppose statistics, you know, always work at the 95% of the confidence level. So if you have a 95% confidence level, then definitely there is a 5% of chance making an error. So based on the 5% of chance, this always comes with a range of the data. So maybe point of estimation, suppose you are taking time to office, you will say on an average, I am taking 20 minutes, but it may be 18 or maybe 22. So based on the 5% chance of error, you are assuming a range that my time to office may be 18 to 22, which is 20 plus or minus 2. So 20 plus or minus 2, 20 is your point of estimation and 2 is the interval of estimation. So this become 18 to 22, which is the 2 is the margin of error. So interval of estimation will be 18 to 22. So in case any time, any given specific value fall between that interval of estimation. Like as in this case, if I say this value, this side is 18 and this side, this value is 22 and maybe your average value is coming 20. And this is your target value. So target value, any given point of time, if it is falling between the given confidence interval, which start from here to here, which means if overlap. So your actual data value, because that comes with a range, if overlaps with the target value, then this is a null hypothesis and p-value will be greater than 0.05. And if this does not overlap, then it's a alternate hypothesis and p-value will be less than equal to 0.05 at 95% confidence level. That's the basic principle behind this. This can be calculated in Excel as well as in the Minitab, and I'm going to show you both. How do we do this and how to calculate the margin of error. So suppose the same example if I take, range is from 18 to 22. Let me take a little broader range. Let's say I generate some random data here, maybe 15 to 25. This is the time you are taking to reach office. I have the data collected for, suppose, let's say this is for last 20 days of the data I have with me. And based on this data, I wanted to compare that on an average, am I reaching in, let's say, 20 minutes or not? So the target you are taking here, 20 minutes. So what is the first thing I will do for my data? I will be calculating the mean value and then I'll calculate the margin of error, which will be defining your interval of estimation. So the mean value of this data, if I calculate, let's say average here, putting up the formula average in Excel, and we get this value. So my current average is 19.45, where my target is 20. Let's say if I'm meeting the target of 20 or not. So what I have to calculate? I have to calculate the margin of error. And your mean value plus or minus margin of error will define your confidence interval. And this is applicable for all statistics. Now, how to calculate the margin of error? So there are two things in the margin of error. You can calculate manual or you can calculate with the Excel formula. So for calculating with the Excel formula, you will need what is your risk level. So risk level is always 1 minus confidence. And if I'm taking 95% confidence level, so my risk what will be here is equal to 1 minus 95%, which is 5%. I got the risk that I am going with the 5%. I have already calculated average value here. What else I need? I need the standard deviation or the variation of the data, which will be calculating by formula stdev dot s. Selecting these values here, I got the standard deviations in 3.03. Now, to calculate margin of error, we will be using the formula in Excel, which is confidence dot norm. Need your alpha. Alpha means the risk, which is 5%. Standard deviation of the data, which we calculated here. And this is asking for sample size. We remember it was 20. That's all. Done. Hit enter. So your margin of error is 1.32. So now what is the interval estimation? Interval of estimation on the lower side will be mean value minus margin of error. And on the upper side, it will be mean value plus margin of error. So now lower side, my mean value is how much? 19.45 minus margin of error 1.33. On the upper side is the mean value 19.45 plus margin of error 1.33. So I got total 20.78. So now the range of the data which I was explaining you in this graph, now let's understand with the help of this graph. So what target you have? Your target value is 20, which is your orange line. And my actually this data is ranging statistically from 18 to 20.78. And 20 value is very much falling between 18 to 20.78 now, because this is the range. This lower side of this left side is 18.12 and this on the upper side is 20.78 and target 20 is somewhere falling here in between. So I will say this is a null hypothesis and p-value will be greater than 0.05. I will help you now to calculate this in Excel with a formula. So there is a one sample t-test. If you go to the data and data analysis option, and in this you will be having the one sample t-test option. So t-test 2 equal variance t-test. No, one sample t-test I think is not available, only two sample available. So let me show you with the same data and target 20, how you can compare this in the mini tab. So I'll just open the mini tab here. I will be pasting this data in the mini tab. And here in the mini tab, you will have the data table. I put it here. First thing, I will be checking the normality of the data. As we know, to check the normality, we will be following the Anderson-Darling test. Click here, select your data. By default, Anderson-Darling, click on OK. And now I will be checking the p-value of my data. If I look at this data, p-value for the normality assessment or normality test is 0.326. If the p-value for Anderson-Darling test is greater than 0.05, which means data is normally distributed. So my first assumption pass. Now I want to compare with a target value of 20. I am comparing this with the target value of average 20. So we'll go to the stat, basic statistics, and here is the one sample t-test. Click on the one sample t-test here. Now you select your data, what you have, because more than sample is one or more sample in each column. So my target here is my time to office. Hypothesis you want to perform against the target of 20. There is nothing in the option. Let it be as 95% confidence level. In case you want to see the graph, you can select like as a histogram or box plot. Maybe I'm selecting histogram here, which will show you graphically the way I was telling you in the Excel that how far you are from the mean value. Click on OK and click on OK. And here we go. So how do we interpret the result? You see this graph as I was telling. Look at the graph. So what you are comparing, the average value of your data is this, and the target value of your data is this. And both the value, as I was showing you in the previous graph, that it is showing like here. This is your actual average of the data, and this is your exactly the target of the data. So this is the graphical representation because you see that statistics Minitab is giving you the range from here to here that values are ranging. Now we calculated the confidence interval based on margin of error. So you can see my confidence interval is ranging from 18.03 to 20.87 and my target value of 20 is very much falling within this value because starting is 18, ending is 20.87 and 20 will fall between this range. So that means this is overlapping with the target value. My actual average is 19.45, which is little less than 20 mathematically. But statistically, 19.45, what we have is coming up with the range of 18.03 to 20.87. And your target value 20 very much falling within this range. So I will say they are same. It's a null hypothesis. And the deciding factor for me, it's a null or alternate will be your p-value. If the p-value is greater than 0.05, then it's a null hypothesis, they are same. If the p-value is less than 0.05, then it's an alternate hypothesis, they are different. So in this case, we prove that it's a null hypothesis and the target value versus the actual observation, there is no statistical difference. That's how we concluded. Thank you so much, people. I'll see you in the next session.